We have been discussing about the properties of fluids. In the previous lecture, we have talked about the density and the unit weight. Now we will look into the third important property of fluid, which is known as the specific volume. How we define the specific volume is it is the volume occupied by any body per unit mass. So we say it volume occupied per unit mass. It's actually the ratio of volume to mass. So specific volume is defined as volume per unit mass. So volume is having a unit of cubic meter and mass is having a unit of kg. Hence the specific volume is defined as meter cube per kg. If I tweak a bit with this formula, I can write it 1 upon mass upon volume. And we know what is this? This is 1 by rho. So hence the specific volume can be denoted by 1 upon rho and the unit stays meter cube per kg. Other important property, a very important property I would like to say, is called the specific gravity. So when I talked about specific gravity, it is the ratio of the density of the substance with respect to the density of the standard substance. So this is the ratio of the density of material to the density of standard material. Please note this definition is a very generic term. If we start talking about fluid, so it will be the ratio of the fluid considered to the ratio of the standard fluid. Now we have to be very clear that when we define fluids, both gases and liquids are the parts of fluid, gases and liquids. So in terms of gases, the standard fluid is air, and in terms of liquid, the standard liquid is water at 4 degrees centigrade. So when we talk about air, the density of air is defined as 1 kg per meter cube, and the density of water is defined as 1000 kg per meter cube. This is defined as 4 degrees centigrade. Usually all questions will be considering the same density. So now let's get back to the numerical which we had been solving in the previous example. So there we have found that the density of the liquid was 900 kg per cubic meter. Now I am asked to find the specific volume and specific gravity. These two things are asked. So simply what we know from the above system is that the specific volume is defined as 1 by density. So I can write it 1 upon 900 meter cube per kg. This value comes out to be 1.1 into 10 raised per minus 3 meter cube per kg. So this is your specific volume. Now let's talk about the specific gravity. You know that we are talking about oil. Oil is a liquid. So the specific gravity denoted by S is the density of oil with respect to the density of water. The density of oil is 900 kg per meter cube and the density of water is 1000 kg per meter cube. If you look here, these units will cancel out. So the specific gravity of oil comes out to be 0.9. So let's focus and give some time to understand that what does this value of 0.9. Let me take some other example. If I say I have mercury with me. So standard mercury is having a specific gravity of 13.6. So if say this is a container with me, and once I fill it with mercury and other time I fill it with water, and this will be having some mass. The system when filled with mercury will be having some mass, and when filled with water will be having some mass. So mass of mercury will be 13.6. It will be 13.6 mass of water. Similarly, we know that weight can also be compared similarly. So weight of mercury for same volume of liquid will be 13.6 times weight of water of same volume of liquid. So this is what we understand, that how heavier a liquid is with respect to the standard liquid.